What is up, nerds? This is part 2 of the Arkanoid tutorial. So in the last tutorial, we imported all of our art assets. We dumped them into the game. We did a little bit of programming for our racket so we can move our racket back and forth. Let's take a look at that, make sure it's still working properly. Come on. It's taking a second. There we go. So our racket moves back and forth. That's exactly what we want. And we can make it move a little faster or slower depending on what we want. How we want our game to feel, just by changing this public variable here called speed. Again, we can change that and it'll allow us to move it faster or slower. Perfect. All right, so the next thing we want to do is we want to bring the ball in. We want to make sure that we have a ball that collides off of the boundary, collides off of the racket, and interacts with the bricks that we're going to put into the game in just a minute. So first of all, let's take a look at the ball sprite. All right. Make sure we set it to 1 pixel per unit and make sure we turn off the filter. So we do not want that. We'll apply that and then we can just drag it right in. We'll just put it right above our paddle. Okay, a couple things we need right off the bat. Of course, we need a box collider 2D. And actually here, instead of a box collider, I'm going to make it a circle collider, just because it's a circle object, so I'm going to make it a circle collider. It's literally the same thing. It'll behave in the same way. We just, it'll be a little bit nicer, a little bit cleaner. So I'm going to create a circle collider. Let's see. All right, now I need to create a new ball material because I want to make sure that my ball can ricochet, just like we did in the Pong lesson. We created a new ball material so that can bounce off of things. I'm going to create a new folder just for my materials. I know I'm only putting one thing in there, but again, want to make sure we keep everything organized. So create a new material, and I'm going to create a physics material 2D. I'm going to call this ball material. Go. And then I want to set the friction to 0 and bounciness to 1, just like we did in the last game. Okay. I'm going to select my ball, and in the circle collider, I'm going to drag the ball material into the material slot. Okay. So now my ball has bounciness, which is what we're looking for. Alrighty. Now we want to add a rigid body 2D because our ball is going to move through the environment. So we're going to add a rigid body 2D. Again, we'll take off the gravity because we don't need gravity for this. We're also going to reduce the mass so that it's really, really tiny and it doesn't push objects out of the way. Uh-oh, I don't want to use auto mass. Okay, make the mass really, really small. Everything else looks like it should be good. We can also constrain our rotation. It's, it doesn't really matter if it rotates, it's a circle. But we're going to just freeze the rotation anyway. All right, cool. So I think that's pretty much it as far as adding objects to the ball itself. We have our material, we have the ball. Now we need to get the ball to actually move. So let's create a new script. So I'm going to go into my scripts folder, right-click, create new C# script. I'm going to call this ball. And I will go ahead and attach this to the ball object. So down here, add component, and script, and hello. It's taking a second. There we go. Oh, add component, physics 2D. Nope, I want script. There we go, scripts and ball. So now the ball script is attached to the ball. And I'm going to go ahead and open this up. If you get this, what this says is basically Arkanoid 2 has been modified outside the environment. That happens whenever you're changing public variables and stuff like that. That's okay. We can just, we can either reload the updated project from the disk, ignore the external changes. Honestly, it really doesn't matter what you click here. I always just click reload. That's fine. Okay. So now we have our ball script. We also have our racket script we could take a look at. Oh, there's another thing you might find. The line endings of the following file are not consistent. Do you want to normalize the line endings? That's fine. Just click yes. We can attach that again, just because it's made changes. But we have our racket script for our movement on our racket. We also have our ball script over here, letting this build itself. Come on. There we go. I'll stop that. All right. Now let's go over to the ball script. Let's actually take a look at it and see what we can do. What we want is we want our ball to move through the environment, right? We want it to start moving whenever the game starts up, and we want it to continue moving all the way until it's done. So I'm actually going to get rid of this update because we're not going to need the update method, and we can keep the start because we're going to actually want it to do something when the game starts. First, we're going to need a public variable, and try to guess what this public variable is going to be. If you said speed, you were correct, because we need to set a public variable for the speed of the ball. Now, that little F I put there, that really just means, you know what, we don't need it. Let's just put 100. We could put the F in there. The F just is for decimals and stuff at the end. Let's see. Okay, so we have our public variable, and we can keep it at 100 because we're going to change it anyway. So we'll just keep it at 100. That's fine. We don't need to get into all that extra stuff right now. So public float speed 100. In the start, we are going to make the start moving, obviously. So get component. Matter of fact, we can actually probably just come over here, copy this, because we've pretty much done this movement already. We don't need to times it by up or by the H because we don't have that anymore. And we don't want it to go right. We're going to actually start it going up. So get component rigid body 2D. We're looking at the velocity of the rigid body 2D. We're going to set it to a vector 2 up, set it going up, and then we're going to times that by speed. That's pretty much it. Now our ball is going to move up. It's going to ricochet off the top, or it's going to bounce off the top. It's going to come down, bounce off the paddle, come up, bounce off the top. Pretty easy stuff. So we're going to attach that to Unity. And we'll go back to Unity, and we will check our ball. Make sure that our script has attached properly, and that we have a public variable. Come on. Stop. Think. All right. So we have our public speed variable, and let's go ahead and test this game out and see if our ball actually does what we want it to. All right, so the ball is going up, bounces off, comes down, bounces off. Perfect. So that's what we need. We want our ball to be bouncing up and down. All right, perfect. So now we need to look at the collision angle of the ball. We want our ball to collide off of this paddle in specific angles, right? So if it collides off of the right-hand paddle, side of the paddle, we want it to bounce off at an angle shooting it off to the right. If it collides off the left side of the paddle, we want it to bounce off at an angle going to the left. This is how our player is going to aim the ball at specific places on the screen. So in order to do this, we could do a bunch of crazy math, but we're actually going to use the power of programming to do the math for us. I'm going to show you how we're going to do this. First of all, this needs to happen inside of our ball script, right? So we're just going to add this to our ball script because this is behavior of the ball itself, so we can add this to our ball script. What we're going to want to do is we're going to want to set a new, we're going to create a new function. We're going to call this on collision enter 2D, and that's something that Unity recognizes. Now when I create this, it creates it as a private. I'm actually going to just get rid of the private. That's fine, we don't need that. And it creates a collision 2D here, and it calls it collision. I'm going to call mine COL, just because I don't want to type out collision a bunch of times inside this method. Or inside this function. So now we have this on collision to enter 2D. If you remember from the Pong tutorial, the on collision enter basically just means whenever it collides with something, when it collides with any other box collider. So when my box collider, when the box collider on the ball collides with a box collider on the outside of the barrier, or collides with the box collider on the paddle, we're going to run whatever's in here, right? So what we're going to do is we are going to, first of all, we want to check to see if it collided with the racket, because we don't want this to bounce off in weird angles when it collides with the outside edge. So we're going to say if COL dot game object dot name equals racket. Okay, so if it collides with the racket, then we want to create a new float, and we want it to be, oh, you know what? We need to calculate hit factor first. Okay. Yeah, let's calculate hit factor, because the hit factor is going to be really important. So let's do this. Outside of this on collision enter, we're going to create a new float called hit factor. And it's going to take in a vector 2 ball position, another vector 2 called racket position, and a float called racket width. Okay, now inside of hit factor, we are going to, let's return the ball position dot x minus racket position dot x divided by racket width. So we figure out exactly where on the racket the ball hit. Right? So that's going to return the hit factor. Basically, it's going to tell us where on the racket did the ball hit, so we can calculate what angle it should come off at. All right, so back down here in our on collision 2D, we're going to create a new float, and it's going to be the hit factor. Oh, come back up. It's going to be a hit factor float, so we can figure out where on our racket the ball hit, and we're going to send it the transform dot position. So if we look here, this is the first thing it's looking for, the ball position. We're sending the actual position of the transform property. So we're looking at the transform property, the position of the ball. So we're going to send that up to hit factor. That's going to be the first thing. And then the next thing is the collided object, the object it collided with. We're going to get the transform dot position. So that's going to be the racket position, right? So the transform position of the collided object is going to be the racket position. And then we are going to send it the collided object, and we are going to look at the collider, and we're going to go bounds dot size dot x, because we want to figure out how wide it is, right? So this is the collided object, the object we've collided with, which we already know it's going to be the racket, because we're only running this code if the object we collided with is named racket, right? So we collided with a racket, so that's the object. We're looking at the collider itself, so the 2D box collider. We're looking at the bounds of the collider, the size of the collider, and we're looking at the x, right? So we want to know how wide is the racket. We're sending that number to racket width. And then that's going to return this calculation. Basically, the ball position and the racket position divided by the racket width. It's going to figure out where exactly it lined up on the racket itself. Okay, now that all that complicated math is done, now we need to do something with it. So, next we are going to, let's calculate the direction. Vector 2 .dir, so the direction that we're going to send it off in. It's going to be a new vector 2, and that's going to be x and 1 dot normalized. Normalized is basically it just smooths off the round edges of these numbers, because sometimes they can get kind of long and crazy, a lot of decimal points. Normalized just smooths it off. So we're going to set that direction. Okay, let's see. And then we want to set the velocity. So what this is doing is setting a direction, which is going to be the, you know, the x value, and then 1. So it's going to set it to a new velocity or a new direction going up, and a new, you know, basically it's going to create a new angle. All right, let's see. And then we want to get component, rigid body 2D dot velocity. Okay, and it's going to be direction times speed. So the ball is going to keep going at its same speed. It's just going to be going in a new direction. All right. Good times. So let's see. I'm trying to think about if I missed anything. No. All right. So let's go over this one more time just so we can understand the logic. So when we collide with something, right? So this is what we're doing. When we collide with something, we're going to call this on collision enter. So the first thing we do is we check to see if we collided with racket. If the game object, the name of the game object we collided with is racket, then we run this code. And what we do first is we create this x variable. It's the hit factor, right? We're calling hit factor. Up here, hit factor is going to return the ball position minus the racket position divided by racket width. Basically, we're going to see where on the racket we hit, where on the racket the ball hit. So we're returning the hit factor. Then down here, we're calculating a new direction based on the hit factor, so where it was, and 1, basically sending it, you know, back up, and we're going to normalize those values. So this hit factor could be, you know, basically where we're hitting on the racket is going to be calculated, is going to be stored also with a value of 1, and it's going to be normalized. This is going to send it off in a brand new direction. So this direction is going to be timed by speed, basically keeping the speed of the ball, and then it's going to send it off in a new angle. And again, it's okay if you don't quite understand all the math that's going on here or what we're doing. As long as you understand the programming idea, the math itself isn't really that critical, because again, the computer's doing a lot of the math for us. We just have to think about it mathematically in order to write this code. All right, let's go back to Unity and let's try it out. Let's make sure that our ball is shooting off at different angles the way it's supposed to. Okay, so the ball's going to travel up, and boom. So you see I hit it on the left side of the paddle, and it went off at that angle. I hit it kind of in the middle, and it went off at that angle. So now I have, my gameplay is pretty much good. I can hit it right in the dead center and it goes straight up. I can hit it on the right side, it goes at a right angle. Perfect. So now my game is working the way I want it to. Alrighty. I think it's a pretty good stopping point. Once you get that ball going off at different angles, you're at a really, really good position on this game. The only thing we have left is to add bricks to the game and then make those bricks go away. And I mean, honestly, we're pretty close to finishing. So that's it for part 2. I'm going to wrap this up. Thanks for paying attention, and I will see you guys next time.